All right, so we're now in a 3.2 talking about completing the square. I had you guys watch a video. You could do it before or after. It'll make more sense probably after, but it's probably good to watch before and after about where we actually get this term completing the square. Why is it called completing the square? So the first thing I want to have you guys try to do here is just do 1, 2, and 3 on your own. So pause the video right away and see how much you can remember from previous classes about solving these equations. So pause the video now and see what you can do. Okay, so you should be resuming now. X minus 5 squared, if you think about 2 squared, it's the same as saying 2 times 2. So the same thing happens here. We have x minus 5 times x minus 5. We're actually going to cover this a little bit more in depth in I think the next section, the next module, but it's still good to remember because you have done this in previous classes. So we do this thing called FOIL, where it's the first, outer, inner, and last terms that we multiply together. So we'll say the first terms in both these groupings would be x's, so x squared. The outside ones, so x and negative 5, which is negative 5x. The two inside ones, another negative 5x. And then the last terms in both of these, which is positive 25. And then we combine the middle, so where we get x squared minus 10x plus 25. Number 2 is actually the opposite. We're going to be undoing it basically and going back to those two groupings. We just talked about this in the last section, so good review. I need two numbers that add to negative 16 and multiply to 64. If for some reason I immediately think 8 and 8, but you can always play around with what numbers multiply to 64. 8 and 8, because it's a perfect square, is just where I go. But it has to be negative 8 and negative 8 because we have a negative 16. So negative 8 minus 8. So then that becomes x minus 8. Oh, 6. And then x minus 8. That's our answer. Number 3, find the missing value that makes each polynomial a perfect square trinomial. So this is where we're trying to find out like what the perfect square is, what we're seeing here, where it's the same thing twice. And if you look at what's going on here, like look for a connection. Let me erase these between these things because you don't know the last term. That's what we're trying to find. But if you look here at the middle, how does that relate to this? How does that relate to this? Well, it's half of it. It's half of it. And then how does that? So negative 10, half of negative 10 is negative 5. Half of negative 8 is, or sorry, half of negative 16 is negative 8. But then you think about how do those relate to, like, how does this relate to this? Oops, to this. And how does this relate to that? Well, you might notice they're squares. So if we take half of the middle, or half of B, then square it, that's how we get C, smiley face. So half of 40 is 20, so 40 over 2, and we'll square it, which is 20 squared, and that's going to be 400. Just an interesting little exploratory thing here, because you're going to see how we're going to apply that in a second. So for B, the same idea, 7 over 2. That doesn't simplify, so we just end up with 49 over 4. Ooh, C is a little bit different though, isn't it? We have an A term. We have that A there. But think about, I mean, it's the same thing. I shouldn't say it's the same thing, but don't overcomplicate it. We're now going to be looking at this and saying, well, the square root of 9 is 3, so we could say 3x. How do we get that C term? Well, we've been doing half of B, so half of 12 would be 6. Square that is 36. But that's not exactly where we want to get to. We have to play around with this a little bit and see how can we get that term or that last term. So I'm just going to guess and check, but I know in this one I'm going to get +2 and +2. You could double check that by multiplying that through. And the last one, we want the middle term, so you might need to be working a little bit backwards because if C If you think about a formula, c was equal to b over 2 squared. Now we're given c is 25. So we have 25 is equal to b over 2 squared. So start by taking the square root, which is 5, is equal to b over 2, and then multiply both sides by 2. So b would be equal to 10. It's okay if you didn't get those. Again, that's kind of like an exploratory little activity. Okie doke. Moving down here. Now we're going to get into why the heck did we do this in the first place. We're going to be calling this completing the square because this is going to take us to the square roots. If we look at this first problem where a is equal to 1, I try to factor that. Can I think of two numbers that add up to 18 or negative 18 and multiply to 5? No, because 5 times 1 is 5, and that's all that multiplies to 5, and they don't add to negative 18. So first thing, we're going to rewrite as x squared plus bx equals c. We don't want, it's the opposite of what we did before where it was equal to 0. Now we don't want it equal to 0. We want it equal to that c number. So let's subtract 5. So we get x squared minus 18x equals negative 5. Now what we're going to do here is we're going to do what we call complete the square. Very vague step. Very vague step. So what that means is we're going to turn this, think about if we have x squared minus 18x plus c equals negative 5, just what we did before. What number would make this factorable into a perfect square trinomial? Or really, we're just looking for something that makes it factorable. So let's see what happens if we follow that step before. We don't know what this is yet. But let's take what we did in those last examples. Let's take half of the b term and square it. So negative 18 divided by 2 is negative 9. And now let's do negative 9 squared. 81. Wow. So we add 81. But think about what we do on one side. That's new. We still have to do that to the other. So that ends up being 76. Now the left side, I could actually factor this right away. What two numbers add up to negative 18 and multiply to 81? Well, negative 9 and negative 9 came from here. So I can just say x minus 9 squared is equal to 76. And then solve this problem just like we did in the last section with the square root method. So take the square root of both sides. X minus 9 is equal to plus or minus the square root of 76. Can I simplify that? Does 76 simplify? 38. It divides by 4 at least. So that was real quick side work. 4 and 19. 2 and 2. Great. I could plot a pair of 2's and leave 19 inside. It's actually plus or minus 2 times radical 19. And then my last step is add 9 on both sides, running out of space. So my final answer is x is equal to 9 plus or minus 2 radical 19. We try not to use decimals. We kind of really don't do decimals anymore in this level of math. We try to keep them in simplified radicals or in fractions or things like that. I guess that would be step 3 was solved by square roots. There we go. All right, but sometimes a doesn't just equal 1. Sometimes we have an a value that's in front, and we have to be taking that into consideration. Let me actually switch this real quick so you guys can see this better. Let's go into something just like that. Okay, so let's take a look. So a in this case is equal to 2. It's not just 1. So, okay, we're going to start with the same steps. Let's start by rewriting this as ax squared plus bx equals c. We don't want it equal to 0 this time. So let's move that 60 over. Subtract 60 on both sides. 2x squared minus 20x equals negative 60. Let's see what we can do with this. For step 2, we can complete the square, but sometimes what I like to look up before I complete the square is look for the greatest common factor. Can I divide some of this out? Well, the nice thing about this is, yeah, everything actually divides by 2. Really like that when something like that happens. So let's just divide everything by 2. We got x squared minus 10x is equal to a negative 30. And all of a sudden, we're back to where we were. Now we can just follow the same steps. So we complete the square. Complete the square. Horrible writing there. And the last step will be solved by quadratics. Solve. Or by square roots. Square. So writing the word square is not easy for me today, apparently. So we'll do, okay, negative 10 divide by 2. This is our new c value. And we'll square it. So it's negative 5 squared, which is 25. So what we're going to do is we're going to add 25 on both sides. Oh, I want a different color. We'll take, whoops. Add 25, add 25. And we'll just go right into the factoring. What two numbers add to negative 10 and multiply to 25? Well, negative 5 and negative 5. So we get x minus 5 squared. That's called completing the square. We take this and turn it into a perfect square. And negative 30 plus 25 is negative 5. But the problem here, when we square root, we get x minus 5 is equal to, oh, we get the square root of a negative. That's not allowed. So actually, we get to a point of being stuck and we just get no solution. What that would look like graphically is if we have our quadratic equation or quadratic function, the graph doesn't actually cross the x-axis. That's what's happening. So the graph is either above or maybe hovering below, like a negative like that. So it doesn't actually cross the x-axis. That's where we're getting these no solutions from. All right, next one here. I'd like you guys to try this last problem, or this number 6, and see how you do, and then we'll continue. So pause the video and we'll go from there. All right. Okay, it's already rewritten. That's good. Do I have a GCF? No. Well, that now poses a bit of a different problem, doesn't it? I can pull a GCF out of the one side at least. 2 x squared plus 6x equals negative 13. That's just going to add an extra step here. So I'm still looking for that completing the square. So I'm looking for something in the middle. There equals negative 13. So I'll still do half of b or square it. So I'll do 6 over 2 squared. So 3 squared, which is 9. So I'm going to add 9 on both sides, except on this right side, I'm not just adding 9. I have to think about if I distribute that 2 back across. That would actually be adding 18. That's the only extra step that we have here. So then we have 2. Complete the square. Some of you might be seeing the shortcut already where you just take whatever the middle is. So x plus 3 squared. And that's going to equal negative 13 plus 18, which is 5. Now from there, it's just a simple solve the problem. Divide both sides by 2. Okay, get a fraction. It's annoying, but it's what it is. So x plus 3 squared is equal to 5 halves. Take the square root of both sides. X plus 3 is equal to plus or minus the square root of 5 over the square root of 2. We have to rationalize that. So let's multiply by the square root of 2 over the square root of 2. So x plus 3 is equal to plus or minus the square root of 10 over 2. And then subtract 3 on both sides. So x is equal to negative 3 plus or minus the square root of 10 over 2. So we get one of those weird funky answers again. All right. We don't have to do each one individually. I feel like that's a question that's going to show up. Is do we have to actually say what's negative 3 plus the square root of 10 over 2? Get an answer. Okay, what is negative 3 minus the square root of 10 over 2? What's the answer? No, we can just leave it written like this. It's actually a lot of more of a clean look. But you do need to include the plus or minus. All right. Last little question to work on. Last 2 questions here. Word problem. We'll rewrite in vertex form and then the word problem. Let's do snip. So maybe you didn't like graphing in standard form. Maybe that sucked for you or was difficult, but you were really good at vertex form. We could always convert these problems into vertex form if we want. So let's set equal to 0. And we'll just follow the same process because we're going to complete the square. Vertex form looks like f of x is equal to, or we can even say y, a x minus h squared plus k. So you see the completed square term there. Okay, subtract 8 on both sides. Let's make sure we get that moved over. So negative 8 is equal to 3x squared minus 6x. I have a GCF on the right, which I'll factor out. So I actually end up with negative 8 is equal to 3 x squared minus 2 x plus something. So let's take half of negative 2, square it. So we get negative 1 squared, which is just 1. So we're going to add 1. But don't forget, if we distribute that, would be a 3. So add 3. So it's negative 5 is equal to 3 x minus 1 squared. Now, because we want vertex form, we're not actually trying to solve this. We want to now get this back equal to 0, because when we switch the f of x to 0, we have to redo that at some point and put f of x back in. So we need to have that side equal to 0. So we'll add 5 on both sides. To be 0 is equal to 3 x minus 1 squared plus 5. And now we can convert 0 back into f of x. If you plug that into your graphing calculator or into Desmos, you would see this and this the exact same. So just a different way to change things up. All right, so last question here. The height y of a baseball after t seconds, after it's hit, we multiply this function. So find the maximum height of the baseball. How long does it take for the ball to hit the ground? So you could go back to rewriting this in vertex form if you want, or you could just find the vertex. It's in standard form, so it's up to you. For the sake of this, I'm going to convert it into vertex form. So actually, I'd like for you guys to start by pause the video and convert this to vertex form, and even see if you can go all the way and get yourself an answer. So at this time, pause the video, and then once you're ready to check your work, you may continue. Okay, so we got this function. We'll set it equal to 0 first. I'm going to switch these to x's just for the sake of writing, because my t's tend to look like pluses. So we'll subtract 4 on both sides. Just got to remember that at the end. Negative 4 is equal to negative 16x squared plus 80x. Now, I should check to see if there's a GCF on that side. Negative 16. Does 80 divided by 16? It does. So I'm actually going to factor out a GCF on the right side. I'm going to say negative 16. Actually, I need to bring out the negative 2. I can't have a negative in front of that as my leading coefficient, or in front of the x squared term. So I'll factor out the negative 16, which then makes this negative 5x. Boom. Let's complete the square. So we'll take half of negative 5. Oh, this isn't going to be fun. Square it. Let's see what this ends up being. Negative 5 divided by 2 squared. Oh, yeah. We get 25 over 4. We're actually going to do this in a fraction for this one. 6.25. Okay. That means over here I have to do that times 16. It's actually nice on this side. So you get 96 is equal to negative 16. X, well, half of 5 is negative 2.5 squared. Okay, then we just got to get it back to 0. Subtract 96 on both sides. Boom. So 0 is equal to negative 16. X minus 2.5 squared minus 96. So that way I can convert the 0 back into y if I want to. So there's my vertex form. It wants to know how long does it take for the ball to hit the ground? For the ball to hit the ground, that'd have to be y is equal to 0, because y is height, right? It says the height of the baseball, 0. So then, actually, what we leave it is a 0. And I'd solve. So I guess we didn't have to go all the way back here. But we'd add 96 on both sides. 6 is equal to negative 16, x minus 2.5 squared. Divide both sides by negative 16. It's going to be kind of funky. Negative 6 is equal to x minus 2.5 squared. Square root plus or minus the square root of -6 is equal to x minus 2.5. Add 2.5 to both sides. Now, the thing about this is we can't have a negative time. We can't go backwards in time. So we only actually end up with one answer, and it's going to be whatever the positive answer for this is. So we will actually plug this in a calculator now. So we'll say, okay, 2.5 plus the square root of 6. Which is 4.95. Does the minus give us anything? The square root of 6. Yeah, it doesn't really give us the right answer. So it's actually looking at x is going to be about equal to 4.94, or x is about 5. All right, completing the square. You're starting to see a little bit about what that or that meme that I showed you guys was before. So now you're starting to see that a little bit showing up here. So we know completing the square and quadratic formula is next. So before you guys watch the next video, I want you to watch a couple of the other ones that like the lesson video. I want you to watch some of those other videos I provided with you just to help you memorize the quadratic formula. And it's kind of interesting and fun. So I'll see you in the next lesson.